Okay, here's my lab setup for the projectile motion lab and then the friction lab as well. So for the post-lab questions, for both of those, here is my completed tables for lab 5, for the post-lab questions as well. And then here is my completed table for lab 7 for the friction lab. So for lab 5, the first post-lab question says, use your predictions of velocity and range from the pre-lab questions and the data recorded from your experiment to complete table 4. So basically, I just filled in the ramp distance, the calculated velocity, the predicted range, the average actual range, and then calculated the percent error from the calculated velocity, and then, or from the predicted range and then the average actual range. And basically my percent errors were, they were a little off from the actual range from what I actually measured, like ranging from about 24 to 20%. And then the second question says, how do your predictions compare to the observed data? Explain at least 2 reasons for the differences. And I said that my predictions were numbers that were at least 0.10 meters apart from each other, and the actual distances were much greater in reality when I actually measured them. And I think this is because the equations I used in the numbers I thought of were a little more kind of like safe and reasonable and a little less random than the numbers I measured. Yeah. And here's my table with all the calculations again. And then for the friction lab, the post-lab questions say, using the result from pre-lab question 2, which for that question, the equation I got was tan theta equals the friction coefficient. I don't really know how to say that. And then the first post-lab question says, using the result from pre-lab question 2, calculate the coefficient of friction for each angle in table 1 and table 2. Find the average value for the coefficient of friction for wood and metal on cardboard. So for wood, that I basically just averaged all the numbers together, and I got 79.2 degrees, and then I took that number and multiplied it by tangent, and then I got the number 5.24, and then for the metal washer, I basically averaged all of those numbers together, and I got 74.6 degrees, and then multiplied it by tangent and got 3.63. And then the second question says, comment on your coefficients of static friction for wood and metal. If they're different, why do you think they're different? If they're the same, why do you think they are the same? And I said that I think these 2 objects are different, mainly because of the weights of both of them, since the block is heavier and the metal washer is much lighter. Gravity kind of affects them differently, which also makes their friction different as well. Yep, so that's it.